Great day, everyone. My name is Dashni, daughter of Tamil Alagan, matrix number S67137. Today, I'm going to present on ocean ion fertilization experiment, past, present, and future, looking to the future Korean ion fertilization experiment in Southern Ocean, KIFES project. Let's begin. First of all, I would like you guys to understand the history of ion hypothesis. 1. What is ion fertilization? Ion fertilization is a technique used to enhance oceanic carbon sequestration in regions where there is limited iron, abundant nutrients, but low chlorophyll levels. This method in turn leads to increased carbon fixation, subsequent export to the deep ocean or sediment via the ocean biological pump. Alright, let's move on with the second question. How did they know about atmospheric gas composition in the ancient time? Well, scientists determined the atmospheric gas composition in ancient time using variety of methods such as analyzing ice core sample, sediment cores, and other geological records. These records offer valuable insight into past atmospheric conditions. Next, how did Martin come to his finding? First, observation of increased gas input during the last glacial maximum. Studies of trapped air bubble in Arctic Atlantic ice core reveals that atmospheric CO2 concentration was much lower during the LGM compared to the pre-industrial time. Martin hypothesis that increased gas input during the LGM could have relieved ion limitation in H and healthy regions, leading to enhanced biological pump activities and carbon sequestration. Next, understanding of iron limitation in marine ecosystem. Iron is a critical macronutrient for phytoplankton growth and its scarcity in certain regions, particularly H and algae region, limits primary production and carbon export. Martin recognized the potential of iron fertilization that elevate his limitation and stimulate phytoplankton growth, thus enhancing carbon fixation and exportation. Lastly, biological pump mechanism. Martin hypothesis has grounded in understanding of biological pump and a process by which carbon fixed by phytoplankton through photosynthesis is transferred to deeper ocean layer through shrinking organic particles. By enhancing the primary production in iron-limited region, Martin proposed that OIF could increase the effectiveness of the biological pump, leading to the greater carbon sequestration in deeper ocean. Well, that's all for history of iron hypothesis. Hopefully you all understand. Now let's move on to the area of iron fertilization. The first question: specify the areas of iron fertilization in the world ocean and why this area have been of interest by scientists and industries. Well, the region of the world ocean targeted for iron fertilization include equatorial Pacific, subarctic North Pacific, Southern Ocean, and subtropical North Atlantic. These areas particularly intriguing to scientists and industries because they are characterized as high nutrient, low chlorophyll zones where the addition of iron could potentially stimulate phytoplankton growth, bolster carbon sequestration. Moreover, these regions play a pivotal role in global carbon cycle and climate regulation, underscoring their significance for investigation of the efficiency and repercussion of iron fertilization as prospectively geoengineering approach to address anthropogenic climate change. Now let's move on to the importance of OIF. The first question: what is the relationship of iron and climate? Based on the finding, how could you relate between high iron and reduced carbon in the atmosphere and vice versa? Oh well, alright. According to the finding, the correlation between increase of iron level and decreased atmospheric carbon dioxide is attributed to the impact of iron fertilization in oceanic phytoplankton growth. By stimulating phytoplankton proliferation, iron fertilization enhances the biological pump capacity to draw down carbon dioxide from the atmosphere. This heightened carbon fixation leads to greater carbon sequestration in ocean, ultimately resulting in the reduced atmospheric carbon dioxide level. For vice versa, diminished iron availability in ocean can impede phytoplankton growth, thereby limiting carbon sequestration and potentially elevating atmospheric carbon dioxide concentration. Alright, let's move on. How many experiments have been performed so far to study OIF in the field? List several limitations that have been classified as potentially caused the unsuccessful finding of the study. Alright, here is the explanation. Over the past 25 years, a total of 13 artificial ocean iron fertilization experiments have been undertaken in diverse regions. Wow! These studies have encountered several limitations that may account for their inconclusive outcome. These limitations include the availability of environmental conditions, uncertainties associated with measurement techniques for export flux, the varying results observed across experiments different due to the experimental condition and setup. Alright, the next question. Are all these experiments achieve the main aim and consider it as a success to remove carbon from the atmosphere and increase carbon sequestration? Not all the experiments have achieved their primary objective of effectively removing carbon from the atmosphere and boosting carbon sequestration. Their efficiency of artificial ocean ion fertilization in enhancing export production has been not definitely established in majority of experiments. Moreover, uncertainties and limitations associated with the measurement techniques and environmental conditions have influenced the outcome of this experiment. Consequently, the success of enduring the accomplishment of their main goal remains a topic of debate and requires further investigation. Alright, let's move on to the last part of our presentation, which is potential future of OIF. Alright, the first question, how to improve the experiment in the future? Well, to improve the future OIF experiment, several considerations should be taken into account to ensure that the main goal of reducing the atmospheric CO2 levels is achieved. Here are some considerations, where first one is location, timing, and duration. Future experiments should be conducted in the center of an eddy structure when gazing pressure is low and fluid levels are high, such as in the Southern Ocean of the polar front during the early summer. Alright, number two, tracing method. The ion fertilization pad should be traced using both physical and biogeochemical tracer to accurately monitor the spread and the impact of ion addition. Alright, the next consideration is measurement parameters. Employing neutral buoyant sediment traps and water column drift thorium-234 method at different depths, along with autonomous profiler equipped with underwater video profiler and transmission meter can help in estimating the carbon export flux and understanding the biogeochemical responses. Next, side effect monitoring. It is essential to monitor the potential side effect on marine or ocean ecosystem, including the production of climate-relevant gases, where decline in oxygen content and the development of toxin alga blooms. Next, long-term studies. Invest in long-term studies to evaluate the persistence of carbon sequestration benefit and potential consequences over time. Lastly, ecological impact assessment. Assess short and long-term impact on marine biodiversity, nutrient cycle, and food webs to minimize disruption to ecosystem. Alright, we are at our last question, which is what should be considered to ensure the future experiment achieve its main goal? By carefully considering these factors, future OIF experiment can be conducted in a manner that maximizes their effectiveness and minimize the potential negative impacts on marine ecosystem and contributing to the reduction of atmospheric CO2 level. Hopefully, everyone understand my presentation and enjoy it. Thank you.